Okay. What is my n value? 5.
Oh.
Does anyone not know how we got 5? Right, my degree is 5. Because I have x squared, and x squared is x to the 4th, plus times x is x to the 5th. Beautiful. And then I solve this. I've got x minus 6 equals 0, x squared minus 4 equals 0, and x squared plus 9 equals 0. So x is going to equal 6, x squared equals 4, and x squared equals negative 9. So then I square root, and I'm going to get x is going to equal 6 plus 2, negative 2, 3i, and negative 3i.
What?
What?
Oh, okay.
When I square root something, how many answers do I have? 2. Yeah? Questions? Square root of 4 is 2 or negative 2. Square root of 9 is 3 or negative 9. And then because it's a negative, I have a I. Cubed has one answer. One real answer, 2 imaginary answers that we never deal with. Okay. So number 2, what's my degree? 6. Then I've got 2x minus 3 equals 0, x squared plus 8 equals 0, x cubed minus 8 equals 0. So add 3. Ooh, why did I put add 3? Subtract 8, add 8. 2x equals 3, x squared equals negative 8, x cubed equals 8. So divide by 2 here, square root here, cube root here, and I'm going to get x is going to equal 3/2 here. 8 is 4 times 2, so that would be 2i root 2 and negative 2i root 2. And then the cubed root of 8 is 2. 2, yeah. 2 times 2 times 2 is 8. And then we have 2 imaginary answers, yeah.
Should you also do square root of 8i and square root of 8?
No.
Okay.
No. You got to simplify the square root of 8. Learn how to simplify square roots. Huh?
Are you recording?
Yes. I know I did good, but I was muted for some reason. Then I unmuted myself. I know. Okay, so we're going to learn how to graph today. It's a lot of describing and not a lot of writing. I just want you guys to know. Okay? Yeah.
Do you actually have people in your Zoom meeting?
No.
What do you record for?
So if people miss class, I record it and put it online. Or if, say, you're at home doing homework and you forgot what I said because you weren't listening,
Oh, okay.
you can go on YouTube and watch. Well, it's actually on Canvas, but it's on YouTube. It's there. But a lot of people go on, like, oh, I'm going to take a 2-week. My parents take me on a 2-week trip to somewhere. And you miss class. Or, oh my God forbid, what if you get COVID this year, right? And are out of school for 2 weeks. Then you have videos and everything's already in Canvas. Does that make sense?
Yeah.
Okay. Okay, so we're going to talk about lovely graphing polynomials today. And the first thing we're going to talk about is shape and end behavior of a graph. So the graph of a polynomial function is smooth. There's no sharp turns or points on it. No gaps, sharp corners, or cusps. So when I draw it, I'm drawing smooth curves, no points, no weird little pointy thingies. Is everyone okay with that? I just want to make sure you know how to do that. Even though my graphs are kind of, I try and make them smooth, but they kind of look pointy. Got to make them smooth curves, okay? Sometimes they're really tall and you got to kind of curve them. Okay, so that's the main thing when we're drawing them. Now we're going to talk about even degree, which kind of talks about our end behavior. So if I have an even degree means I want to think what I want to say about this. What is an even degree? Let's talk about that. What's an even degree? What is even?
Positive leading coefficient.
Now, what's even?
An even number.
What's an even number?
2.
Right.
Something
So an
that can be
even,
divided by 2.
something that can be divided by 2, right? Even degree. So 2, 4, 6, dot, 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 dot. Right? Everyone understands the even degree? And the degree is the highest exponent, right? So that's my degree. So as long as it's even, if I have a positive leading coefficient's the number with that highest degree variable. Oh my Lanta. Okay, so if I have a leading coefficient that's greater than 0, okay, so it's positive greater than 0. Okay, I want you to look at the 6. There's 6 of them. Great, 6 graphs. Describe what all of the graphs have in common. So look at them for a minute. Tell me what they all have in common.
Okay.
Okay, so what did you guys come up with? Yes, Adrian.
They all tend to go up.
Where at?
They all start at above the x-axis.
Okay, so the endpoints start and end above the, so you're talking about here and here, right?
Yeah.
Right. So all my endpoints go up, right? So I could probably, I don't know. So let me write this. Start and end above the x-axis. Is that what you said? That's what you meant, right? Same thing? I put it more simply. They all open what? Up. So my endpoints are all going up, right? So if I'm looking at my ends, where my arrows should be, just so you guys know. I mean, I'm sure teachers have told you. But when you're doing technology, they don't really put the arrows on the ends of the graphs. So those all have arrows on them, okay? So they all open upwards. So if I have an even degree and a positive leading coefficient, they all open upwards. Okay, so that's what the end of my graph will always look like. Okay. And then we'll go into the next page. And we've got a negative coefficient this time. So describe what they all have in common now. This one all opens down, okay? So again, if it's an even degree and I have a negative coefficient, they're all going to open downwards. No matter what goes on in between my endpoints, like I have a whole bunch of stuff happening in here, right? A whole bunch of stuff. They all open downwards, okay? Whole bunch of stuff in here. I'm just looking at the endpoints. They're opening downwards. Okay, questions? We good with that? Yes, go ahead. So I'm looking at 2 things right now. Just the first thing I'm going to look at is the degree.
Yeah.
Is it even?
Yep.
Or is it odd? If it's even, and then I'm going to look at the leading coefficient. Is it positive or negative?
Yep.
Positive, it goes up. Negative, it goes
Yeah.
down. Okay?
Okay.
Not too bad so far?
Yeah. It's good.
Awesome. Okay, now let's go to odd degree. What does odd degree mean?
Something that can't be divided by 2.
Okay, something that can't be divided by 2, right? 1, 3, oh my goodness, 5, ... right? Can't be divided by 2. Everyone okay with that definition? Awesome. So go ahead, take a second. Are they all on there? Yeah. Tell me, basically, they start negatively. Is that what you guys said? Negative. Give me all these big words. Negatively, and then what?
And positive.
And positive. Positive. I'm very simply going to put it this way. Has a positive slope. Because look, from endpoint to endpoint, if I drew a straight line, what's happening? Positive slope, right? No matter what's happening in between, they all have a positive slope. So as long as I have a positive leading coefficient, I'm going to start low on my left side and go high on my right side. So I have a positive slope. Yeah?
Okay, yeah, I get it.
Okay. And then what happens if I have a negative coefficient?
You start high and low.
Yeah, start high and low.
That's how you don't want to throw the stock market.
It has a negative slope. No matter what's happening in between, it has a negative slope. Which we know, I just want to point out, if I have y equals negative x, that's a 1 degree polynomial, right? First degree has a negative slope. We know that. It's a negative 1, right? My slope's negative. Everything else also has a negative slope. Even with all this other crazy stuff that we're going to learn how to graph in it, it still has a negative slope if it has a negative coefficient. Does that make sense? The rules don't change just because I have all this other crap in there. It doesn't change. It's still negative. Does that make sense? Okay. All right, so which one of the graphs could be the graph of f of x equals negative 3x to the fourth and...
I went back to my freshman teachers and I'm like, you were my teacher for like 9th grade? Are you sure?
Okay, so what does it just tell me? It tells me it has an even degree, right? So which one? So if it's even, they're either opening up or down, both the same direction. Which means it's not A and it's not C. I don't have my glasses on, I can't see. Okay, so it's it's either B or D. The next thing I'm going to look at is that it's a, negative coefficient, which means it's opening which direction? Down. So that means it's not D and it's B. Okay? And why? Because I just explained it. So even degree, negative this is not even better for me. Efficient. I think that's right. Coefficient. You can tell when I can't spell words because it gets really, really super sloppy. I mean, I write sloppy anyways, but when I can't spell something, it gets super sloppy. Okay, questions? Not too bad so far? Okay. This one's a little more confusing, but we're going to talk about it anyways. Because we have to. I just want you to say we have to. Okay? Yeah, we have to. Number of turning points. At most, I have n minus 1 turning points. N is the degree of my polynomial. Okay? So if I have a degree 2, we all know how many turning points do I have on a quadratic. I have 1 because it's a U shape, right? So n minus 1 turning points. Degree 3, I have at most n minus 1. So this, I'm just going to tell you this graph right here, this second one, is y equals x cubed. That's what it looks like. Okay? Looks like this little weird flat thing in the middle here. Flats out because we have 2 imaginary answers there. Okay? And it goes through 0. Or I could have 2 turning points. Whew. I can have a point here and a point here. Just depends on where my x-intercepts are. And where my x-intercepts are tell me how many turning points I have. Okay, if I have, remember when I had, on the warm-up, I had x cubed minus 8. And we solved that and we got x cubed equals 8 and x equals 2. This would look like this graph, only where would it go through the x-intercept at? 2. So it would look like this, only slided through 2. Because it only has 1 x-intercept and 2 imaginaries. Is that kind of, right? This one would have 3 x-intercepts. Okay? And at 4 here, 4th degree can have 1, 3, or 3 turning points. Here, I have 2 x-intercepts and 2 imaginary. Notice, see how it's flattening out here?
Yep.
That means I have, once it starts flattening out, it means I have imaginaries at that point. So it's 2 imaginaries, 2 real x-intercepts, 2 imaginaries. And then I've got 4 x-intercepts on the next one. to the 5th degree. Oh, let me show 3rd and 5th. I want to blow that up. Can you see it all? Look at the difference between a 3rd degree and a 5th degree. What's the difference here? It's more flat. I hate to say more flat. That's not necessarily good English. But notice how it's flatter here than on the cubed.
Could we say the flatter part is longer?
Yeah, it's longer. Yeah. Okay.
But
This is
that's
x
still-
cubed. So if it was 7th, do I have a 7th up here? Guess what? It would be even longer.
Okay.
And 9 would be longer. And 11 would be longer. Okay? Does that make
But
sense?
it's still x cubed.
This one would be x to the 5th. This is a 5th degree.
Okay.
X to the 7th would be longer. X to the 9th would be longer. Just longer there. Okay? And then I've got 1 degree here. I have 1 x-intercept.
You just.
I hate it when it does that.
Why are you on a notepad?
I know, but I like being up here sometimes too. But when I touch the smartboard, it does that. So here, I have 2 bumps. I've got an x-intercept. If I don't touch it with my finger, it'll be okay. I have 1 x-intercept. Okay, I lied.
Just don't touch it with anything.
I will just touch over here.
Just touch it with
So weird. Okay, I have 1 here, and I've got 4 here. Some of them are imaginary. Oh, I have to have 5. Okay?
That x-intercept.
So I've got 1 x-intercept here, and then imaginary ones here.
And those are 4 imaginary numbers.
There's probably 1 real because it does touch the x-intercept, and then it's imaginary.
Okay, so there's
Okay?
2 imaginary,
Yep.
1 other imaginary, and 1 real number.
We're going to talk about when it touches the x-axis and when it doesn't, when it crosses, when it only touches.
Were you not here? Oh, yeah, you weren't here yesterday. Someone got wheeled out in a stretcher here.
Oh, that's lovely.
That was yesterday? Yeah, that was yesterday.
Wow, okay.
That
No, I was not
good
here
to see.
yesterday. And then I can have 1, 2, 3 turns. These, and I'm going to talk about it right now. I know I have 3 x-intercepts, right? When it comes up and touches and comes back down, just like here, it came and touched, it didn't cross the x-axis. That means there's, I want to make sure I word this very carefully. That means there's more than 1 at the same place. So remember when we had the equation that said, I had like y equals x minus 1, times x minus 1, x plus 3. Remember we had that? And we were talking about multiplicity. We're going to talk about multiplicity now. This means I have a multiplicity of 2 at this point and a multiplicity of 2 at this point. So there's 2 x-intercepts here. There's 2 here. And there's 1 here. So that gives me a total of 5. 5 x-intercepts. And then this degree 6, I have 1 x-intercept, 1 x-intercept, and 4 imaginary. That gives me 6.
Wait,
Yeah.
I was paying attention for degree 5 on 4 bunch.
Yeah.
How is that -2, 1, and negative?
It's not -2. It's 2 intercepts here and 2 intercepts here. That gives me a total of 5.
Okay, so.
Is 2
Okay, it's kind of like doing this.
Yep.
Okay.
I have just 2 in that same spot.
Is there 2 intercepts because of...
So remember when I had this? Can you see that? Oh, sorry, you can't see that. Remember when I had this?
Yeah.
X minus 1 and x minus 1? I had 2 in the same place.
Yeah.
That's how you graph it here. It goes up, it touches it, and bounces back down. That means I have more than 1. Okay? So if I have more than 1 here, see how it flattens out? That means I have more than 2 there. So I probably have like 4 there. Okay. This one is degree 6 again. I have 1 x-intercept, 1 x-intercept, and probably 4 in there. Okay. So that's how that works. 5 bumps, 1, 4, 1. Okay. So, which equation, which equation could represent this graph?
Um,
Okay, that one's right.
This one. Okay, wait. So it's opening upwards. It's opening up.
It
You
is
can say
opening
that.
up. Good.
Okay. The endpoints, but it's really infinite, are positive. It
Nice
could
job.
be a negative or positive leading coefficient.
No, I'm pretty sure it could only be one.
And there's only even degrees.
Mm-hmm. Very nice thought process there, Adrian.
Yep. It's opening upwards.
So, is it going to be, what type of leading coefficient is it going to be, positive or negative?
Positive.
Why?
Because it's opening upwards.
Because it's opening upwards. So that means it can't be A and it can't be C. Great. So what's my degree? Even or odd? Even. So what's my degree of B?
2.
No.
You said B.
Yeah, I said what's the degree of B?
Yeah, 2.
No. 4.
Why is it 4?
Because I've got a squared here, which means x times x is x squared. And then another x and another x would be degree 4. What's my degree of D? 5. So which answer is it? B. I didn't even need to know anything else. I didn't need to know about the terms. I didn't need to know about anything else. I just needed to know if it was positive or negative coefficient and what degree it was. Does that make sense? Just so you know, a lot of ACT questions, super easy to figure out like that. Okay, if they give you something like this.
So it's B.
B. Okay. So now we're going to go to the whether it touches or versus across. I hate using cross. This is the word I use. You can use cross if you want. I like you not touch. Cross is the right word. Sorry. Yeah. I use the word kiss because it makes you guys remember it better. Is it crossing or is it kissing? Okay. So at the x-intercept. So I'm going to zoom in on this one real quick. Can we see that? Great. So I have my equation. I've got my x equals. And notice at -6 it crossed once, and at 7 it crosses once.
Yep.
And it crosses, right?
Yep.
And if we look at here, on this equation, I've got -6, and I've got 2 7s, because I've got 2 here, square, yeah?
Yep.
So it's x plus 7, so we've got 7 twice. So at -6 it crosses, but at at 7 it kisses it,
Oh,
or
because it's
touches
not
it.
technically going
Because
under.
there's 2. There's 2 7s. So how do I show that there's 2 7s? I'm going to come down, touch it, and bounce back up.
It's not because it's not going under it.
Nope, it's not because it's not going under the thing. It's because I have 2 x-intercepts at 7.
Okay.
Okay? And because if I look at the other one here, it's not because it's going under, because look, here I've got 2 -6s coming up, touching, so it's not crossing,
So I have to look
and one at 7. If I got an odd, I'm just going to point out, this is an odd number. What is it doing?
It's going up.
It's crossing.
It's
If I have an even number, what's it doing? Bouncing. It's kissing, touching, bouncing, whatever you want to call it to remember it. The axis, and going back in the same direction.
Yeah.
Okay? So here we have 2 the same. They're both even. -6 and -7. So I'm touching at -6, going back up. Touching at 7 and going back up. So if 2 of the same answers, it bounces. If I have an odd number, it crosses. Cross versus touch. So let's put that into words. What's the difference between a touch and a cross?
Touch?
Kiss, bounce, whatever you want to call it.
Touch
What's a touch?
Is when it's squared.
A touch is when I have
Two of them.
two of the answers.
Yeah.
I'm going to say an even answer.
Okay. And then a cross is when it's odd. Correct?
Touch. I should say odd number of the same answer. Gosh, I should spell that better. Let's do this better.
You just made us write this stuff down.
Yeah, but it doesn't quite, when I wrote it down, it didn't make sense. When I have, because if you look back at your notes, I want it to make sense, right? And I have an even number of the same answer. I just had to put a few more words in there. You get a touch. And when I have an odd number of the same, just had to add of the same answer in there. We get a cross. Okay? Now we're going to talk about multiplicity, which we kind of talked about the other day, right? I said, remember this is coming up when we're graphing?
You wait right there.
Okay, I can wait right here. Ooh, I had that blown up quite a bit. I could have written a lot longer across there.
Thank you.
You're so welcome. So let's talk about multiplicity. The number of times a given factor appears in the factored form of an equation of a polynomial is called multiplicity. The zero associated with this factor, x equals 2, has a multiplicity of 2 because the factor x minus 2 occurs twice. So that's what they're talking about. So if I look at a multiplicity of 1, so I'm going to zoom back in. So in this graph, each of the x-intercepts have a multiplicity of 1 because the graph passes straight through the x-intercept. It just passes straight through. It doesn't flatten out. It just goes straight through. That's a multiplicity of 1. That means I just have one answer for each of those x-intercepts. So I have x equals -7, -2, and 4. Okay? Right there. Multiplicity of 1. Everyone okay with that? Yeah. Now, even multiplicity right here is the next one. The graph touches and rebounds the x-axis when the particular x-axis has an even multiplicity like 2, 4, 6, etc. So here at -4, that's so small I can hardly read it. At -4, I have a multiplicity of at least 2. Okay, and then I've got 1, 2. So this one has a multiplicity of 2. So this would be a 4th degree polynomial. Now I will say this, and I'm going to draw it off to the side. If it's 4 or 6, when it comes up to the, I'm going to blow this up so I can draw it right. When it comes up to the axis like this, if it's 4, it's going to be more flat. And if it's 6, it's going to be flatter. And if it's 7, 8, it'll be more flatter. The more multiplicity you have, the flatter it is at that point. Okay? So at 2, it just goes up, touches, and comes down. If it was 4, it'd go up, be a little flatter, and come back down. Okay? 6, it'd go up and be more flatter and come back down. Okay? And then odd multiplicity. As soon as Sammy gets back, honey. Okay, odd multiplicity. The graph sort of lingers around the point of interception before actually crossing. This happens when I have multiplicity of 3, 5, 7. So here has a multiplicity of probably 3. Actually, I would probably say that's more. But again, the same thing. If it had a multiplicity of 5, it would be even flatter. And 6, it would be 7, it would be flatter. The more I have at that point, the wider that little crossing point is. Okay? So that's how that works. So great. Okay. Max number of intercepts. Max number of x-intercepts. The max number of x-intercepts is the degree. Okay, that's the max number of x-intercepts. If I have a 4th degree, I can have 4 intercepts. If I have a 5th degree, I can have 5 intercepts. Can I have less than that? Yes.
You will always get.
Yes.
So if you get a 2 degree, you will always have 2 intercepts.
Yes. No. Yes. Yes and no.
No, yes.
No, that's the max number I can have.
Oh.
Okay? Because think about a quadratic, which you said, right?
Yeah.
I can have 2 intercepts.
Yeah.
I can have 1 intercept.
Yeah.
Or I can have 2 imaginary intercepts.
Yep.
Okay? Yes? I still have 2 intercepts, they're just imaginary. And I have 2 here because it went down, kissed it, and went back up. Right? Or touched it, or rebounded it, or however you want to call it. Okay, I call it kissing it. So it kisses it and goes back up. So it has 2 there. Okay? So it does have 2. It just looks differently.
Okay.
Okay?
Cool.
Even multiplicity looks like I just drew even multiplicity, just so you guys know. So even multiplicity will look like this. Woo, right? It touches and comes back up. Odd multiplicity will go up. Flatten out a little bit. Ooh, that was actually pretty good. And then crosses. So odd multiplicity crosses.
What's the right definition, or just do it?
You can, if you need to write it out in words, then write it out in words. So an even multiplicity touches, right? And odd multiplicity flattens out and crosses. Flattens out and crosses. Touches, sometimes flattens out. But it always touches. Even always touches. Odd always flattens out and crosses. Always crosses. Okay? Whew. This part, I'm going to tell you the truth. This part's probably the hardest part about graphing. Huh? Was the first part easy?
Yeah.
Okay, that part wasn't bad, right?
Yeah.
It's this part that's hard.
Yeah.
Yeah. I'm not going to lie to you. It's this part that's hard.
Also figuring out
Okay. All right. So what is the minimum possible degree of the polynomial function graph below? Woo.
that. 5. 1, 2, 3.
5. Yeah. Because they all go straight through. They don't flatten out. So it's 5. That's it. That one was super easy. Because I have 5 x-intercepts. So now given, this one's a little harder. I'm going to give you some time on it. Given that a polynomial is of degree 6, doesn't matter if it's negative or positive coefficient. It just says that it has a degree 6. Which of the following could be its graph? Let's start with what it can't be. If it's 6th degree,
A.
if it's a 6th degree polynomial, what for sure could it not be?
A. E.
I said, what can it not be? Can you guys see this? What can it not be?
A. E.
It can't be D. Why can it not be D? Because the n degree is open which way? Opposite. So anything where my n degree is open opposite, it cannot be. So it cannot be that one or this one for sure. So if you chose those two, I'm sorry.
You're wrong.
Yes.
It can't be A.
Why not?
Because there's only 2.
But it flattens out at the bottom.
Yeah, but it doesn't matter.
Yes, it does.
It doesn't.
It does.
It doesn't. It will still won't add up to 6 though.
Okay, look back at your picture. Turn the page back. I just want to point this out. I can make an argument for it being 4. Look back at right there.
Oh, yeah.
I can make an argument that there's 4 imaginary intercepts right here. Because it flattens out, correct? So I could make an argument. That's the one I would make an argument for, that it could be A.
Oh,
Okay?
could it be E?
So I'm going to say, yeah, A. And the same reasoning goes for E. Great. Okay. Okay? So now let's zoom in on some of these other ones.
It's negative, so it cannot.
It doesn't say if it's negative or positive, so it doesn't matter. Okay? It just talks about the degree, not the leading coefficient. Are you okay with that?
Yeah.
Okay. So I've got 1, 2, at least. So there's 1 here, at least 2 there, 1 there, 1 there, and at least 2 there. So that gives me what? 8. So it can't be B. So that gives me 8.
So that when it touches, it counts as 2?
At 2. At least 2. Okay? If it touches and bounces back down,
And
right?
And then if it crosses, it's 1.
Unless it flattens out. If it just crosses through, it counts as the 1. So let's talk about F. So here counts as 2. This counts as 1. This counts as 2, which gives me 5. I know this has got to be an odd degree, right? Because it crosses, so that's got to be a minimum of 3. So that's how many? Too many. Yeah, that's right. Good. That's too many. That's a minimum of 8. So it can't be F. So C. So I've got 1 here. And I've got 1 here. How many do I have here?
4.
Yeah, probably 4. So it could be C. And then we said it couldn't be G. And then H, right? This goes through, so it's got to be an odd amount. This goes through, it's got to be an odd amount. It looks like it's the same odd amount, just going to say. So could it be 3 and 3? Sure. So those are the ones that I chose. Does everyone understand why I chose those ones now?
Yeah.
And do you really understand? Are you just saying yeah?
On H,
H, yeah.
on the bottom where it crosses the Y.
We're looking at x-intercepts, not y-intercepts. Yeah. Does that help?
Yeah, that's what I thought.
Yeah. Okay. So, hey, we're doing great. So we are gonna graph a few today. We're gonna graph 2 today, and then tomorrow, Thursday, we're gonna graph a whole bunch more. Okay. So when we're graphing, we're gonna look at 5 things. I'm like 4 things. 5 things. I'm going to use the degree of the polynomial to determine the overall shape of the graph. Use a leading coefficient to determine the end behavior of the polynomial graph. Determine the real zeros, the x-intercepts. Determine the y-intercepts. And maybe plot a few more points. So what is my degree?
3.
Degree 3. What's my leading coefficient? Oh. What's my leading coefficient? 1. Anybody not know how he got 1? Bless you.
Me.
Okay, so if I multiply x times x, I get 1x squared. Times x gives me 1x cubed. What's my leading coefficient? 1. Okay, awesome. Okay, my x-intercepts.
6, negative 2, negative 7.
6, negative 2, negative 7. Anybody not know how we got those? Okay, y-intercept. How do I get my y-intercept? Anybody?
Don't you want to make everything equal to 0?
I want to make x equal to 0 and
Yeah.
solve for y.
Yeah.
So there's a 0, 0, 0. So 6 times negative 2, negative 6 times 2 is negative 12 times 7 is negative 84. Is that right? That's right, right?
What was it? 12?
7 times 12, 84? Yeah, I think that's right.
I'm looking at it.
Okay. Yeah, I know. We're going to pretend it's on there.
You just made every x 0, so
Yeah.
negative 6 times negative 2. Sorry, negative 6 times 2.
Yep.
Negative 12.
Okay, so I'm going to go ahead and plot the points that I know. I have 6. Maybe I'm going to plot them. 6, negative 2, negative 7, negative 84 is way down there. not. It's much further, but we're going to pretend it's there, okay? Negative 84. I just put it below the x-axis, below my graph. Right. Negative 84. Okay? So, talk to me about my end behavior. Where's my graph starting at?
6.
Are they going to end in the same direction or opposite? Are they starting opposites, right? Because it's an odd degree. So is it starting low and going high or starting high and going low?
Starting low, going high.
Starting low and going high. So I'm always drawing my graph from left to right, just like we read and just like we write. We go from left to right, right? Pretty easy. So I'm going to start low. I'm crossing all of them. So I'm going to start low. Go up, come
I
down.
don't know where to start.
I just picked a point and started.
Okay.
We are not, let me do this. We're sketching the graph. It said I could plot a few more points if I wanted to. How do you do that? Pick a point, plug it in. Tells you where to start. But we just want the general shape. Okay? This is the general shape. Did I hit my important points? Yes, that's what's important. I hit my important points, okay? Which are my x-intercepts and my y-intercepts. And then I started in the right place and ended in the right place. Okay, now I'm going to talk about end behavior really quick and how you write it. End behavior. So we've talked about it. You guys kind of know, like, if it's even, it opens up, right, or opens down, or goes this way or goes this way, right? But there's actually a mathematical way to write it, and if you see it in delta math, you'll be going, huh, what? Okay, so I want to show you how it's written. So as x goes to negative infinity, what's happening to y? So as x is going this way, what's happening to y?
Positive infinity.
Y is not going to y.
Oh, sorry, negative.
Negative infinity. And as x is going to positive infinity,
It's going positive infinity.
right, y is going to positive infinity. Okay, that's how you write it. Sometimes they use f of x instead of y. And then you have to be careful in the delta math because sometimes for some reason they put y first instead of x. So make sure you're reading it because for some reason they flip it sometimes. So make sure you're reading it carefully.
Wait, as x equals goes to negative infinity, it's going positive infinity?
No, it's going to negative infinity. As x is going to negative infinity, y is going to negative infinity. Right? As x is going this way, y is going...
Oh, I'm reading it
this way.
downwards. I'm not reading left to right. I'm reading as x is going to negative infinity, x is going to positive infinity.
No, read it across. As x is going to infinity, y is going to infinity. Okay?
Yeah.
Okay. So this is how end behavior is written. So they usually write f of x. Sometimes they write y. But you guys know f of x and y are the same thing, right? Okay. So I want you guys to try the last one before I do. Sorry.
That's all right.
I keep forgetting about connections. Okay, so what's my degree? What's my leading coefficient? Great, what's my x-intercept?
-1, 8.
And 8. I have 2 8s.
Oh, shoot.
Why do I have 2 8s? Because this is squared. Okay, and what's my y-intercept? What's my y-intercept?
Is it 8? Or is it 8?
No,
Positive 64.
no.
Negative 128.
It is -2 times 1 times -1 times -8 times -8, which is 128.
Wow. Wow. Okay. We were all 1 times -1, -1. -1 times 8, -8 is 8. 8 times -8 is -64. -64 times -2
It's 128. Okay, go ahead. So look, this is squared, so I have to square my -8. I can't forget that square. Which I think you guys did, right? Hey guys, class doesn't get out till at least 10:03, so sit down. It's not even 10 yet. Why are you putting stuff away and not paying attention? Okay? Okay, so this is squared, so I have 2 8s there. -8 times -8. And then I've got my, these are all zeros, and then you can't forget your -2 that's in front. So it's 128. Is everyone okay with that? Yes, no, maybe.
Yes.
I'm just putting a 0 where the x is, so I have everything else there. I can't get rid of the squared. I can't get rid of the -2. Everything else is still there.
Can I see you? Can you put the x values in?
Yeah, I'm going to graph it right now.
Okay, perfect.
So I've got -1, 1, and 8. Oh, that's not 8.
Okay.
What happens at 8?
Miss Camelot.
Yes.
So the x values are always going to be the opposite ways.
Yes.
Okay. I was worried there for a second. I thought I graphed it wrong.
No.
Okay.
Okay, what happens at 8? I have 2 values at 8. I have 8 multiplicity of 2. What happens when I have a multiplicity of 2? Does it cross or does it touch? Touch. So at 8, it's just going to touch. How is it going to look? I have a degree of 4, so what's going to happen? N goes in the same direction or opposite directions?
Same.
Same.
Yeah.
And it's an odd leading coefficient, so it's up and up or down.
Down.
So it's going to look like this, right? With a whole bunch of crap in between, basically. Yeah?
Will we have that little chart that shows us all the degrees on
No.
the point? Okay.
Nope.
Okay.
So then it goes, oh,
Yeah, studies to do.
down. But the checkpoint that you're taking is not going to be graphing, so it's just solving. Oh, it's just solving. We're not even done with graphing yet. It's just solving.
And that checkpoint's next class?
Yes. Okay.